An idea born in unsettled times.
We are going forward. America, the United States, is first in space.
Becomes a feat of engineering excellence. The most complex machine ever built to bring humans to and from space.
Roger, roll, Discovery.
And eventually construct the next stop on the road to space exploration.
We are on a true spaceship now.
As 30 years of flight draw to a close, its legacy is one of unsurpassed achievement, tragedy overcome, and opportunity met. NASA Space Shuttle. Space Shuttle Endeavour is rolling out to Launch Pad 39A at NASA's Kennedy Space Center in Florida. In 24 missions, flown over 20 years, Endeavour has logged more than 103 million miles in space. The last of NASA's shuttles to be built, Endeavour prepares for her final flight, STS-134.
I marvel at when I see the space shuttle up close and personal, behind the panels where we have hardware, plumbing, black boxes, electronic devices, and that sort of thing. The workmanship that I see in this is astounding. And that points right at the people that do this. When you integrate all that together, it results in what I think has been a marvelous program with the space shuttle.
Well before any shuttle reaches the launch pad, however, a staggering amount of work is required. The parts, plans, and people necessary to make each launch span the entire nation. One single goal is the focus: the safety of the orbiter and her crew.
You've got all these people, all these folks that are in their 20s, some of them in their 30s, and they are, no kidding, in charge of some part of the space shuttle, some part of the space station, or some part of the plan. And every one of those people absolutely believes that they are the one that makes the difference on getting those astronauts back down to the ground alive.
At NASA's Mission Assembly Facility in New Orleans, production begins on the shuttle's external fuel tank. The last of 136 produced here since 1973. Each one 154 feet tall and 27.6 feet around, is capable of handling 535,000 gallons of liquid hydrogen and oxygen, enough to fill 13,375 average household bathtubs. 3 versions of the external tank were created during the program in an effort to reduce the tank's overall weight and allow for heavier shuttle payloads. Around the same time, in Clearfield, Utah, technicians at ATK Launch Systems start work on the shuttle system's solid rocket motors, or boosters.
Fire.
Together, these SRBs produce nearly 6 million pounds of thrust, about 83% of the thrust needed to push the orbiter into space. The remaining 17% is furnished by the shuttle's 3 main engines, fueled by the external tank. Unlike the orange external tank that is used only once, the boosters detach themselves and parachute into the Atlantic Ocean. They are then retrieved, refurbished, and reused on later missions. The shuttle mission's crew is assigned.
Folks on there that are like my brothers and sisters. I mean, we really do get close after a year of training for a flight and having flown in space together. And there's a special bond that comes with that.
Right up until launch, a shuttle crew will train in a variety of critical regimens, some basic, others specific to their mission. Simulators, safety and contingency, science experiments, and underwater in the world's largest indoor pool. STS-134 astronauts floating in actual spacesuits trained to work during extravehicular activities, or EVAs. The Neutral Buoyancy Lab, or NBL, at NASA's Johnson Space Center in Houston is the best simulation of microgravity on Earth, and ideal for practicing spacewalks.
One of the most amazing facilities that we work in is the NBL, the Neutral Buoyancy Lab. And the divers and the guys who help us run the robotic arm are all there to ensure that our spacewalks are flawless. Their efforts in that pool have helped us and made us able to have this program.
Every step of a spacewalk, every step of EVA is so critical, and even though we see it every day, that one little safety tether could be life or death.
For every hour that they spend in orbit, they'll spend 5 to 6 hours training for that same task. So we've built up from the suit engineers and suit technicians who help them get into the suit. Now we've got trainers who help them learn how to use the suit and learn how to understand the suit. And then we've got divers who support them while they're in the pool. The closer they get to actually flying in the suit, the team of people who help them tends to grow. Maybe not exponentially, but it's certainly getting bigger.
A 12-person crew has kept a week-long vigil, while the barge, carrying the ET, made the 900-mile trek from Louisiana to Florida's central east coast. The iconic orange external tank finally arrives at the Kennedy Space Center. 1 month later, the ET is mated to the solid rocket boosters to form the backbone of the stack. Now, all that's missing is the spacecraft itself. When an orbiter returns from a mission, processing for the next flight begins almost immediately. It's a task requiring no less than 650,000 hours of labor. This includes the removal of its 3 liquid fuel engines and their replacement by 3 from a previous mission. They've been refurbished, inspected, and tested at the Stennis Space Center. With most of its flight preparations complete, Endeavour is towed in what is called the rollover, a short roll over a quarter-mile distance on a 36-wheeled vehicle from the Orbiter Processing Facility, the OPF, to the VAB. Here it undergoes its flight configuration. The rollout. Looking now much like it will at liftoff, the space shuttle is carried to the launch pad atop the 6 million-pound crawler transporter at a blazing pace of less than a mile an hour. Not exactly warp speed.
At our peak, carrying full load, we get right around 38 feet per gallon.
Not too bad for an original 1965 hybrid vehicle with low miles. The 3.4-mile journey takes up to 6 hours. Just enough time to appreciate the route's picturesque surroundings. Kennedy Space Center is situated on a national wildlife refuge. Bald eagles, osprey, and vultures are just a few of the scores of bird species regularly spotted in local skies. Both land and sea are home to a wide variety of creatures, including manatees, dolphins, and of course, the ever-present alligator. Visitors are always urged to watch their step. Now on the launch pad, the orbiter is ready to take on its main payload. Testing assures that the multi-ton cargo is secured and safely stowed in the payload bay before the technicians certify the orbiter is ready for launch. Flying T-38 aircraft from Ellington Field in Houston, the crew members arrive at Kennedy's Shuttle landing facility.
But finally the day comes when you're there and you're getting ready to launch. And you go into launch countdown and it's like going up the hill on that roller coaster. It's full of expectation and you're both thrilled and terrified at the same time because anything could go wrong, but when it goes right, it's a thing of beauty.
If there are no issues or concerns, technicians begin fueling the external tank with volatile, liquid hydrogen and oxygen.
The predominant emotion is pride. There's a tremendous sense of pride in all that not only that you do, but that your teammates do, that people in this very firing room do, and folks all across the country.
This is Shuttle Launch Control, T-minus 9 minutes.
At the T-minus 9-minute hold, the launch director leads one final pull.
We finally come out of the hold at T-minus 9 minutes. I sit back and I watch my data, but I know that there are souls on board that ship whose lives are depending on the launch team to make the right decisions. I don't think about that consciously, the decision-making authority and responsibility. I know it's there, but I do think consciously about the crews and the people we're about to put on top of a controlled explosion and get to orbit.
This is the NTD conducting the launch status check. All stations verify ready to resume count and go for launch. OTC, OTC go. TVC, TVC go. PTC, PTC's go. LPS, LPS is go. Houston flight.
Houston flight is go.
After nearly 3 years, hundreds of thousands of hours logged by engineers, technicians, scientists, seamstresses, electricians, and other program workers across the globe.
We have main engine start. 2, 1. Booster ignition.
The shuttle makes its way skyward. At liftoff, 6.6 million pounds of thrust begin hurtling the vehicle and crew at speeds that'll reach 17,500 miles per hour. The shuttle is like no other machine ever built. For its launch to succeed, more than 1 million parts must move together perfectly. How this engineering marvel came to be is an amazing story that begins in the early 1970s. The Vietnam War is divisive and costly. The economy is sliding into recession. And with the race to the moon already won, the Apollo program is canceled. A new mission is sought for NASA to send humans into space. But Mars, for many the next logical step on the path of exploration, is dismissed as too costly, a destination for a country preoccupied with events back on Earth. Instead, on January 5th, 1972, another destination is selected, low Earth orbit. As early as the mid-1960s, NASA had concluded that the technology was available to build and fly a reusable spacecraft.
President Nixon really liked the idea and told the NASA administrator, go do it. And the NASA administrator got a call from OMB the next morning, someone there, and said, hey, what the president really meant to say was, you're going to get this much money, and so do as best you can with the space transportation system. And our choice, logically, was you have to have a vehicle first, and so that was the birth of the Space Shuttle as the first in the 3-part space transportation system.
Many designs were considered. Often, they combined the best features of different concepts.
At that time, they were looking at having jet engines on the shuttle for landing and for transporting it across the country.
The idea of the lifting bodies was to bring astronauts home to conventional runway landing. Previously, all of our spacecraft, which were capsules, came down in the ocean. Someone came up with the idea of a vehicle that could land like an airplane.
The key thing was to understand aerodynamic stability across the hypersonic, supersonic, subsonic, and landing speed type of environments that a single vehicle has to fly safely. That was the key thing that was learned from those, and you'll see it reflected in the shape of the space shuttle.
One was the use of a lifting body, an aircraft with no conventional wings. Only its fuselage would keep the aircraft airborne and guide it safely back to Earth.
They were known as the flying bathtubs. For the first test, the M2F1 was towed behind a car, a souped-up Pontiac. Whitey Whitesides drove that Pontiac across the lake bed at about 120 miles per hour, dragging this flying bathtub behind it.
As well as groundbreaking, their tests could also prove ground shaking. The X-24B, a lifting body with wings, was the first such craft to land on an actual runway, as all shuttles would eventually do.
Early on, the space shuttle was going to have jet engines to return for horizontal landing, much like an airliner. The X-15 had proven fairly specifically that they can make horizontal landings very accurately, unpowered, flying a steep glide slope, that they could do a horizontal unpowered landing with the shuttle.
As they tried to narrow its size, shape, and weight, engineers also considered how this new orbiter would be propelled safely out of the reach of Earth's gravity. At the Marshall Space Flight Center in Huntsville, home of the rockets that had sent every Mercury, Gemini, and Apollo astronaut into space,
All engine running. Liftoff. We have a liftoff.
design teams would devise the partially reusable propulsion system that would finally be adopted.
The main engines were always something we paid very close attention to. Lots of moving parts, lots of high energy in very tight places, and very cold liquid on one side of a very small wall and very hot on the other side. When that thing finally lit off, for me, it just showed the power of a space shuttle main engine, and then there's 3 on the back of an orbiter, and then there's the 2 solid rocket motors. That was probably the spark that got me so interested in the space shuttle program in general, and what it took to actually get 1 engine to light, much less 3 and 2 boosters to take the shuttle to orbit.
As for the orbiter, spiraling costs forced NASA to abandon equipping it with its own jet engines and escape pod.
Originally, it was going to be an air-breathing airplane that would fly to space as a rocket and then come back to Earth. The orbital maneuvering system pods that sit on the back now were to be where deployable air-breathing engines would come out, and it would be able to fly from its intended point of landing to another place if the weather were bad or something like that.
NASA's new shuttle would essentially glide its way back to Earth. Producing the components of this new space transportation system fell to familiar names in the space industry. Prime contractor Rockwell North American, now Boeing, had built the Apollo Command Service Module. Morton Thiokol, now ATK, would build the solid rocket boosters, and Martin Marietta, now Lockheed Martin, would construct the ET. Responsibility for producing the space shuttle's main engines went to Rocketdyne, now Pratt Whitney.
There's a lot of teamwork that was going on. It was bringing people from all across the country, from Kennedy, from Johnson, from Marshall. So many people involved that had to work together. Now, at the beginning, there was a lot of anxiety that we weren't going to work together. But when people got to know each other and could trust each other, that's when the work began.
It was an amazing vehicle, and in a lot of ways way ahead of its time. To have a reusable spacecraft that could carry such tremendous amounts of cargo to space was unprecedented.
September 1976, more than 4.5 years after President Nixon signed off on its development, America's new spacecraft, Constitution, gets its first close-up before the cameras. The orbiter itself was well received by the public, but impassioned fans of a particular long-canceled television series called Star Trek wanted it called something else. They staged a successful write-in campaign, and the orbiter was renamed for the Starship featured on the show. Thus, NASA's new shuttle would be the Enterprise, boldly going as no spacecraft had ever gone before. Whatever its name, this bird still needed to prove it could fly. In an age before computer simulations, balsa wood models and wind tunnel testing was the only means to test the airliner-sized glider.
We put together a very aggressive flight test profile that consisted of data points continuously all the way down. There was not a matter of 10 seconds went by without another, either a pitch doublet or a rudder kick or an angle of attack sweep, the things that really turn on a test pilot to fly them as accurately as possible.
August 12, 1977. On a crystal clear California morning, high above the Mojave Desert, 2 NASA test pilots ready for Enterprise's first flight. The plan was for Fred Hayes, Jr. and Gordon Fullerton to lift the orbiter off a modified 747, then land on a dry lake bed 15,000 feet below.
The thing that we were most concerned about was if we were going to be able to get to a launch speed, if Fitz Fulton was going to be able to put the 747 into a slight dive so that we would have enough lift on the Enterprise to, when we did push the separation button, blow the bolts, to lift away from the airplane without hitting Fitz's tail. And of course, both of us were interested in that happening.
The pilots on the 747, Fitz Fulton and Tom McMurtry, sit and wait for the command to release and steer their massive aircraft out from under Enterprise.
There were still questions about, was it going to actually happen as we expected from those simulations and the analysis and everything. There's a very loud thump when the shuttle separates. There was always a question, was the shuttle going to slide back and hit the tail of the 747? But we couldn't see that, but we could, after a few seconds, we could tell it didn't hit us. And so the chase called clear.
Once we reached the 240 knots and Fitz called on speed, I think he really pushed some of the sensors he was looking at in order to let us get to there, and we appreciated that. But once we heard Fitz say on speed, I pushed the separation button and we just broke free. We had about 1.5 Gs of lift.
Honestly, that was probably the most exciting moment in the approach and landing test, to feel and be there when the shuttle separated from the 747.
By all accounts, this first freefall test is a success. 5 weeks later, Enterprise is brought to 22,000 feet for her second freefall test. Pilots Joe Engel and Dick Truly have only 2 minutes to capture flight and maneuvering data before landing the aircraft again without any engines.
It was a real team effort, and the challenge was for Dick Truly and I to fly that profile and fly those data points, those maneuvers, as precisely as possible to give them the best data possible. It was a test pilot's dream.
A total of 16 taxi, captive, and drop tests confirmed the soundness of the craft's design and green-lighted production of the first space-worthy orbiter. Columbia, NASA's first orbiter, is fittingly named after the first American vessel to circumnavigate the globe. However, Columbia quickly becomes a daunting challenge for NASA. Its complex makeup had engineers struggling constantly to reduce Columbia's weight and simplify construction. Especially frustrating was keeping the orbiter's ceramic tiles attached to its fuselage. More than 25,000 of them fit together to protect Columbia from the searing 3,000-degree heat of re-entry.
We were having a lot of problems with the thermal protection system of the tiles. The way we were trying to glue them on, they wouldn't stay on. And we had to come up with a way of making sure that they'd stay on. And we had some really great people that worked that, and that's why it took such a long time. I had hoped it was not going to take that long, since John and I were named as a crew, so we had a lot more time to train than what we'd both initially planned.
The requirement was to be able to handle temperatures like 2,500 degrees F that occur on the surface of the TPS, and that's 5 times what your oven is at home that you bake cookies under at max. The other problem is weight, because after all, this is an airplane, so you can't have a metallic system on it that weighs tons. It has to be extremely lightweight. And in fact, the shuttle tiles are about 90% air, and that gives the combination of being able to be temperature resistant and yet at the same time light.
Each orbiter has a unique number of protective tiles. Challenger was built with the most, 31,088, while Atlantis has the fewest, a mere 24,177.
Over in Palmdale, they had put on their first effort of putting the tiles on to protect the aluminum from the heating they were going to get on reentry. And some of those tiles, when they'd put them on in the daytime, next morning the tiles were on the hangar floor. And so that was real scary that we could lose some tiles while they were on orbit and really have a problem with the heat coming back on reentry.
Columbia had a lot of tiles missing yet, needed quite a bit of work before we could deliver it to the Cape. And we scrounged throughout the city of Lancaster for RTV, which was the material we used to glue the tiles on with.
More glue did keep the tiles in place. However, water was literally ripping them apart.
It turns out, in the instant we hit rain, the tiles almost exploded.
The tiles fabrication process was modified and the problem overcome. Other shuttle design features proved less problematic and more groundbreaking. A computerized digital flight control system, now common in commercial and military aircraft, was developed for the orbiter.
In flying the space shuttle, you were so aware that you weren't necessarily talking to the shuttle, you were talking to a computer who in turn was going to talk to the shuttle.
Barriers of race and gender were falling everywhere, and America's corps of shuttle astronauts would become more reflective of the nation it served.
There's been a lot that the shuttle era has done to bring space flight into the domain of the average person. We know it's not just crew-cut white test pilots anymore. It's essentially the United Nations that flies on the space shuttles. It's people of every description that look very much like the rest of us.
The astronaut selection process reflected a changing nation and a changing NASA.
At the time, all the astronauts were military test pilots and there were no females, so it was kind of like one of those dreams that you hope will happen someday, but you didn't really think would.
The NASA astronaut class of 1978, the largest in the agency's history, came from all walks of American life: physicists, meteorologists, fighter pilots, scientists, and for the first time, women and African Americans.
When I came into the astronaut program in '78, there were 3 African Americans that came in at the same time, and it was the first time that NASA had hired African Americans. We had Fred Gregory, who was a test pilot, and then Ron McNair, who was a mission specialist, and I came in as a mission specialist. So all 3 of us were excited about flying in space, and all 3 of us recognized that we were really going to open up the envelope for other African Americans to fly in space.
While the new class of NASA astronauts trained for subsequent shuttle flights, Columbia was undergoing preparations for the program's maiden voyage, STS-1. Veteran astronaut John Young, one of the 12 men to set foot on the moon, is in command. His pilot is first-time flyer Bob Crippen.
To be sitting on board up there with my buddy John Young and get to experience the whole thing from ascent and being on orbit to flying re-entry, it was one of the high points of my career.
Together they would travel over 1 million miles and circle the Earth 36 times.
The launch finally occurred. We'd been waiting and postponing, and when it finally lifted off and we knew it was going and achieved orbit, we were all in anxious anticipation for what was going to happen next.
Launched like a rocket 2 days earlier, Columbia lands as a glider on the dry lake bed of Edwards Air Force Base in California.
Watching out the window, watching the sea and the clouds rush by, it actually gave a sense of speed, more so than when we were up in orbit, being much higher. I think they were all very relieved because there had been some concern because we had lost some tiles initially on the orbit, and they didn't know whether we'd lost any on the bottom or not. flew down over the San Joaquin Valley. We do a big turnaround to land on the lake bed for that first flight. I remember when John went into a bank, a big left bank, I looked down at the lake bed, and there's thousands of people out there on the lake bed. John, look at all those folks, which had come out to see us land.
Joe Engle was chased, and hear his voice coming in on final, talking to John Young and Crip in the airplane that they were right on glide slope, coming in for a landing. And then have that landing, and then have John Young do his Young dance. He was just so elated. It was such a magnificent flying machine to him at that time.
The first time I really saw a real shuttle was Columbia, when it was out on the lake bed after the landing, and I'm walking around it. I couldn't believe they sent that big a mass up in the air.
People really thought this was all impossible. So what we have done and shown and demonstrated through the shuttle program is we've shown that we can take the impossible and make it possible.
Thousands of spectators line up along the landing strip to greet the shuttle and its two-man crew.
Anyone who was associated with the program or there just to see the shuttle return, I think felt a lot of pride in our country and our space program. And so those emotions were, finally released, and you said, wow, the flight was done safely. They're back home. The shuttle really does work. It's a great program. It's got a great future ahead of it.
Hey, this thing works, and we got it back all in one piece, which is what we wanted to do.
While Columbia's return was spectacular, it would renew NASA engineers' worries about the shuttle's thermal protection system. During the post-landing inspection, 148 of the orbiter's tiles were found shattered, and 16 more were missing due to the effects of an overpressure wave. While that and other issues were addressed, the 50-ton Columbia would be placed atop the specially configured 747 and ferried back to Florida and processing for its next mission.
It's a massive enterprise. It's over 8 stories tall, sitting on the ground, and you never get over that site. It's really awesome.
After the shuttle lands, there's a processing procedure for the shuttle. Post-flighting it, checking the tires, checking the struts, measure it, get the correct measurements. And then when the shuttle is ready to mate with the 747, we would tow underneath, and then they would lower the space shuttle down on the supports on top of the aircraft. We would take off.
On takeoffs from the extra-long runways of Edwards Air Force Base, the shuttle carrier aircraft's crew of 4 would soon grow accustomed to the smell of burning rubber. That's the intense heat generated by their plane's spinning tires as they carried 2 massive aircraft at more than 100 miles an hour. The average range of a 747 is about 5,000 miles, but due to its weight, configuration, and special flight requirements, the SCA can travel only 1,000 miles at a time. A full turn in the jet can take several zip codes.
32.5. Switching up, thank you.
Cruising at more than 250 miles per hour, the jumbo jet burns 40,000 pounds of fuel per hour. That's 130 pounds per mile, or the length of a football field per gallon. No wonder it has to make several stops before reaching Florida's east coast.
We would get a spacecraft back, go over it again, be sure that we could reuse it, repair it where we had to do. It had never been done before. And so I think that's one of the marvelous things about the space shuttle was we found a way to turn this spacecraft around and use it again.
Before the end of 1982, Columbia would fly 4 more missions.
Liftoff of America's space shuttle,
including STS-5, the first with a crew of more than 2 astronauts. Challenger, the second orbiter in the shuttle fleet, made her maiden flight on April 4th, 1983.
and liftoff of the orbiter Challenger and the 6th flight of the space shuttle.
STS-6 deployed a communications satellite and featured the first spacewalk of the shuttle era. Just 2 months later, Shuttle Challenger was back in orbit, this time with the first American woman in space. Physicist Dr. Sally Ride was a member of Commander Bob Crippen's STS-7 crew that deployed Canadian and Indonesian satellites during the 6-day mission. Challenger was ready for flight in less than 2 months, another massive first. Shuttling the first African American to space, and Air Force combat pilot Guy Bluford.
For me, it was an exciting moment because it was something that I had been training for 15 to 16 months, and so I was looking forward to the experience of flying in space.
We are in an era of brotherhood.
We have liftoff of mission 41D, the first flight of the orbiter Discovery.
In 1984 to 86, the newest orbiter Discovery would fly a record 6 missions.
And liftoff of mission 51D and the 7-member crew of Discovery.
Carrying into space satellites, international astronauts, even a U.S. senator and a congressman. 1 year after Discovery's debut, Atlantis flew her first mission.
Liftoff of Atlantis. A new orbiter joins the shuttle fleet and it has cleared the tower.
STS-51J. It was also one of 7 classified missions the space shuttle would fly for the Department of Defense. By the end of 1985, the space shuttle program had completed 23 missions, including 9 that year alone. Each successful flight had the unintended consequence of convincing some that spaceflight, once considered among humankind's most inherently dangerous endeavors, had become routine. That notion would soon be tragically dispelled.
Well, I am so excited to be here.
Amid much fanfare, Krista McAuliffe, an elementary school instructor from Concord, New Hampshire, had been chosen from among 11,000 applicants to be NASA's first teacher in space.
I would like to humanize the space age by giving a perspective from a non-astronaut, because I think the students will look at that and say, this is an ordinary person. This ordinary person is contributing to history, and if they can make that connection, then they're going to get excited about history, they're going to get excited about the future, they're going to get excited about space.
The American public's interest in its space program was renewed by her participation and was eager to see her off. Commanding the flight was Dick Scobie. His pilot was Michael Smith. Serving as Challenger's mission specialists are Judy Resnick, Ellison Onizuka, and Ron McNair. Joining McAuliffe as a payload specialist was Greg Jarvis. From the start, STS-51L was plagued by delays, mostly due to unseasonably cold temperatures in Florida. Rather than give pause for thought, the delays only tried the nation's patience. Everyone, it seemed, was itching to go. January 28th, the ground temperature at Launch Pad 39B was a frigid 36 degrees. Ice could be seen on the launch vehicle. Despite concerns voiced by some, shuttle managers reluctantly decided to press ahead for a late morning liftoff.
6. We have main engine start. 4, 3, 2, 1, and liftoff. Liftoff of the 25th Space Shuttle mission, and it has cleared the tower.
Challenger, go with throttle up. Challenger, go with throttle up.
At 11:39 Eastern, twice the speed of sound, the Challenger's fuselage breaks apart from the inside out. America's space program suffers its first fatalities in flight.
God, no.
All 7 Challenger crew members perish.
Okay, everybody, stay off the telephones. Make sure you maintain all your data. Start pulling it together.
We come together today to mourn the loss of 7 brave Americans, to share the grief that we all feel, and perhaps in that sharing to find the strength to bear our sorrow and the courage to look for the seeds of hope.
The investigation, headed by former Secretary of State William Rogers, would fault a solid rocket booster O-ring, rendered defective by the bitter cold. But the Commission's findings also addressed the human factor, the role played by shuttle program managers in sending Challenger aloft that day. The shuttle program came to a halt It took more than 2.5 years of arduous engineering analysis and painful soul searching before a retooled and reborn shuttle would return to flight.
Challenger was tough because it not only represented a breakdown in communications, but it represented everything that's wrong or wrong about an agency like we are, where segments of the agency weren't talking to each other and didn't know everything that we should know.
We thought we knew where all the risks were and had them pretty well contained. The solid rocket boosters that caused the accident, obviously there was something that had slipped through. So we went back throughout the complete vehicle, all the systems, and did a complete review and trying to find any other things that we may have missed that may be lurking there.
When things are really starting to look smooth and you're starting to get maybe overconfident in a way, then it's time for you to step back, think about what you're doing, go back and look, do some additional testing, and see if there's something that you really hadn't anticipated that is going on with your systems.
During a lot of that time, we got a lot of criticism that maybe the agency had lost its edge. There were folks inside the agency that started losing their confidence, thinking maybe we can't do this anymore. 2.5 years later, when we flew and then landed that flight, it showed that no, we really can overcome really, really large problems, really tough technical problems today, just like we could 10 years ago, 20 years ago, or 50 years ago. That was an important milestone.
And liftoff. Americans return to space as Discovery clears the tower.
On September 29, 1988, 975 days after the loss of Challenger and her crew, the orbiter Discovery returned 6 veteran astronauts to space to deploy a tracking and data relay satellite important to a number of NASA missions. STS-26 proved a comeback milestone for the Space Shuttle and initiated a tradition that survives with the program today.
During the flight, we had roses show up in the Mission Control Center. 6 roses, 5 red, 1 white. And there was a card attached to it, and it simply said, "Congratulations, return to flight, we wish you well." And it was signed Mark, Terry, and Mackenzie Shelton. Didn't know who they were, but after the flight, we through the Foro company, we tracked them down so we could send them some pictures and something to thank them for sending the roses to Mission Control. So the next flight, roses show up again. And again, it's 5 roses for the members of the crew and 1 rose for those who have lost their lives in this endeavor. And so this family, they have become part of our family, and they haven't missed a flight since. Every flight since that time and to date, and I suspect they're going to go right with us to the end of the shuttle program.
STS-26 ended on October 3, 1988, at Edwards Air Force Base, California,
Standing by for nose gear and touchdown.
with Discovery's safe landing on runway 17. The triumphant crew was greeted warmly by Vice President George Bush on behalf of a proud and grateful nation.
There's something special about a return to flight that makes you have some trepidation because it's still fresh in your mind that you're frail and you can make mistakes and you're human.
In the spring of 1990, the $1.5 billion Hubble Space Telescope was loaded into Space Shuttle Discovery's payload bay, and on April 24th was sent aloft to be deployed to Earth orbit on STS-31.
Capcom, we have a go for release. Discovery, go for Hubble release.
Okay, we have a go for release.
As envisioned, Hubble would return never-before-seen images detailing our universe as it was millions upon millions of years before. Soon it would become clear that Hubble pictures were not.
Several days later, if not a couple of weeks, we found out after we were back on Earth that it had a problem with its vision. And most of us were just devastated, that here we had this marvelous instrument that we had put on orbit and it was going to be useless. It turned out that it wasn't useless at all because even with its flaw, it was still a much better telescope than anything that we had, on Earth.
A shuttle mission dedicated to the telescope's repair was planned. In essence, Hubble's nearsightedness would be corrected with a new pair of glasses.
Liftoff of the Space Shuttle Endeavour on an ambitious mission to service the Hubble Space Telescope.
We finally flew STS-61, which was the first Hubble servicing mission. Absolutely incredible mission.
Clearly we have a dynamic situation.
You cannot take the 84-inch mirror out of the telescope. It's part of structure, too big, it's there.
So by putting in one box called CoStar, we're able to correct the aberrated light for 5 other instruments.
Of all the space shuttle missions we've flown, it was without a doubt the most ambitious flight, but the one that I think demonstrated NASA's can-do attitude, its technological skill, its technical capability, and the spirit of its people.
2 teams of astronauts made a record 5 back-to-back spacewalks to refurbish Hubble and realize her potential to awe and astound. While Hubble servicing missions were very important, the true gift of a maneuverable shuttle was soon realized in a very different rescue mission.
Booster ignition and liftoff of the maiden voyage of Endeavour on a satellite rescue mission.
Months earlier, in May of 1992, the 7 astronauts of STS-49 overcame initial setbacks to pluck the $180 million Intelsat 6 communications satellite from an unusable orbit.
It was going to be a very simple rendezvous, get close, bring the satellite down close and grapple it with the remote manipulator system. Everything that could go wrong went wrong.
We got up there to capture it. The bar, we tapped the satellite with the bar, and the satellite started moving out of control.
Get me in. Pitch me over. Into the arm. Watch the end of the arm.
That's a singularity again.
You're going to have to get out of there.
It can be very difficult catching something like a tumbling satellite in space. The slightest touch or mistouch by the astronaut with the equipment, and you can send that satellite tumbling.
Here, make sure that when you want me to yaw right, you say yaw right. Okay. Any other time right is just right. Yeah, that's what I'm doing. Better move. We're moving.
And so it was very touch and go on that mission, actually.
Commander Dan Brandenstein and pilot Kevin Chilton are preparing for the upcoming terminal initiate burn.
After several days of failed attempts with Endeavour's remote arm, Commander Dan Brandenstein literally tries a new approach.
Yeah, real easy, guys, real easy. Don't bring us any closer, Dan. Okay, I'm stopping it.
At Endeavour's helm, Brandenstein delicately maneuvers the orbiter up to the 4.5-ton Intelsat 6.
The satellite is rolling out of control in 3 different axes at once, and you could actually fly the shuttle and fly this maneuver around and keep it aligned with it.
It's got to be the neutral point right here.
3 people grabbed 18,000 pounds.
Aware that any miscue could endanger not only the satellite but also the ride home, spacewalkers Pierre Thuot, Tom Akers, and Rick Heeb reach out and secure the satellite by hand.
Okay, wait. Let's do it. Got it. Easy. Give it some time. Give it time. All got a good grip? Yes, sir. Houston, I think we got a satellite.
Yeah, nice job, guys.
Intelsat 6 is released from the cargo bay with a new mini-rocket motor for a gentle push to its proper orbit, where it remains today, fully functional. And as the shuttle program matured, so it seemed did relationships between the world's spacefaring nations. On STS-47, the 50th Space Shuttle mission saw the orbiter Endeavour back in space on September 12, 1992. The mission was a cooperative Spacelab venture between Japan and the United States that brought the first Japanese astronaut into orbit as a member of the 7-person shuttle crew.
The Space Shuttle has launched people from different nations around this world that used to feel they could never, ever work together. And it has ushered us from the Cold War to this really cooperative space program that we have with our international partners, including the former Soviet Union.
Regardless of what language you speak and love space, and that's pretty cool. We have a lot in common with engineers and scientists around the world, and that's kind of fun to work in a program like this.
On February 3, 1995, Eileen Collins, the first woman to pilot a shuttle, was at the helm as Discovery gave the U.S. its first up-close look at the Mir space station. Collins flew the shuttle through a series of intricate maneuvers, approaching within 37 feet of the Russian spacecraft and later performing a fly-around by hand.
And liftoff of the Space Shuttle Atlantis on a mission that will herald a new day of international cooperation in space.
4 months later, on June 27, 1995, Shuttle Atlantis would lift off from the Kennedy Space Center to begin STS-71, the U.S. space program's 100th human space mission. It would take 2 more days before Atlantis caught up with and performed the first shuttle docking with the Mir space station.
Houston, Atlantis, we have capture.
Orbiting 220 miles above the Earth, a most unique and historic celebration took place. As the Mir space station welcomed its first American guests, cosmonauts and astronauts together broke figurative bread, tortillas and fruit to be exact, in a renewed spirit of cooperation. Together, Shuttle and Mir formed the largest flying spacecraft the world had yet to see. It tipped the scales at 250 metric tons, more than 500,000 pounds. Between 1994 and 98, the Shuttle Mir program would involve 11 shuttle missions, including in 1996 STS-76, which began a continuous U.S. presence aboard the Russian space station with a visit by Atlantis. Barely fluent in Russian, astronaut Shannon Lucid, a biochemist, embarked upon a mission that would dramatically enhance our understanding of life in space. When she finally landed at Edwards Air Force Base on Shuttle Atlantis, she held the female space endurance record for spending 188 days in orbit. A hero's welcome was in store.
I'm here to say welcome home to Shannon Lucid.
By the time Shuttle Mir ended with STS-91, 7 American astronauts had completed extended stays aboard the Russian space station.
Tatiana Mativa, who I became very good friends with, and I remember us sitting in Red Square having dinner together with a full moon, and remembering when I was a child all those parades, those May Day parades with the tanks going by, and here we were sitting there having a nice dinner under the full moon and with a lot of friendship. So it just goes to show how space can unite people, and that's I think one of the biggest benefits.
8 cosmonauts had flown to Mir on the U.S. Shuttle, and NASA astronaut Norm Thagard had become the first American to fly there or anywhere aboard a Soyuz spacecraft. In 2001, 15 years after its commissioning, Mir would be abandoned to break up and burn in Earth's atmosphere. By then, the process of building upon Mir's legacy of international cooperation in space had already begun. Whereas STS-61 had helped establish the Hubble Space Telescope as an icon of American ingenuity, STS-95 would update the hero's credentials of one John Glenn. On October 29, 1998, almost 37 years after becoming the first American to orbit the Earth as an original Mercury 7 astronaut, Glenn, now a 77-year-old former U.S. Senator, made his return to space. In contrast to his first flight, a 3-orbit, 4.5-hour foray inside the snug Friendship 7 capsule,
Liftoff of Discovery with a crew of 6 astronaut heroes and 1 American legend.
STS-95 would take 8 days and circle the Earth 134 times.
My main reason for being on that shuttle flight was to do research on aging. I was 77, we went up, and NASA has charted some 52 different changes that occur in the human body when you go into space for a period of time. And several of those are very similar to what happens to the natural process of aging right here on Earth. Body's immune system changes. You get less resistant to disease and infection. The body's ability to absorb protein back into the muscles changes for the young people up there and for elderly here on Earth. The objective was to take those things that are the same and see if we couldn't find any differences between my experience up there and the younger people I would fly with the idea of finding in the human body what turns these different systems on and off. If we could do that, we might be able to make it possible for people to stay in space longer without harmful effects, and maybe cut out some of the frailties of old age right here on Earth. I really was happy to be assigned to that flight.
In an interesting twist of fate, astronaut Glenn not only inspired both the young and old around the globe, but also a fresh political science and economics graduate, Laurie Garver, the 18th Deputy Administrator of NASA.
Having the ability at NASA to fly him again in space after his first flight was something we, I think, gave the nation, and it really helped explain what we were doing on the space shuttle. John Glenn was very, very focused on doing those experiments for both, I think, the older generation, but he was also an inspiration to people growing up.
Discovery carried a variety of payloads and research experiments. Arguably, the one most valuable was Glenn himself. Not only did he provide first-time data on what spaceflight might do to the body of a septuagenarian, Glenn also renewed the interest of the nation and the world in America's space shuttle program. While the program had and continued to successfully deploy and service science probes and satellites, as well as conduct on-orbit research, the space shuttle undertook a new long-range task perfectly suited to her specialized capabilities.
You've got a spacecraft that can carry at least 7 people into orbit, and with those 7 people, you can do a huge amount of work. One mission, you can do multiple EVAs, you've got multiple crew members, you've got a huge payload, just all kinds of capabilities to be able to construct and build bigger things in orbit.
Less than 2 weeks after Glenn's return to Earth, a Russian Proton rocket departs the Baikonur Cosmodrome in Kazakhstan, carrying the Zarya module, the first component of the new International Space Station.
Liftoff of the Proton rocket and the Zarya control module. The International Space Station is underway.
2 weeks after that, Space Shuttle Endeavour follows up with delivery of America's Unity module, the second piece of this largest space station puzzle ever to be constructed.
Houston Endeavour, we have capture of Zarya.
Not until July 2000 will the Russian Zvezda module be added, finally allowing for 2 Russian cosmonauts and their American Expedition 1 commander, Bill Shepard, to journey aboard a Soyuz spacecraft to the International Space Station and begin humankind's continuous extraterrestrial presence.
Across the world, people are very, very interested in and delighted by the International Space Station and the science that has taken place there.
Since only an orbiter's payload bay could hold the station's largest components, the multi-year, multi-mission building, outfitting, and servicing of the ISS with cargo and crew would become primarily a job for the shuttle. Amid these dynamic station-building missions, one seemingly simple and relatively uncomplicated flight would prove problematic and threaten the very future of America's human spaceflight program. Since 1988, the Space Shuttle had completed 15 years of successful missions. Each was unique, each had its own specific goals and tasks, and each had its own dedicated crew of astronauts who'd trained exhaustively to meet and carry them out. Yet each of those 87 flights did have 2 things in common: a safe launch,
liftoff of the Space Shuttle Discovery,
and a safe landing.
Nose gear touchdown.
From the start, STS-107 seemed to be a mission out of sorts. By the time Columbia was finally ready to fly on January 16, 2003, its planned 16-day mission had been delayed no fewer than 18 times. All those delays had ultimately positioned the STS-107 as a sort of black sheep on the Space Shuttle program's launch schedule. Columbia's crew commander Rick Husband, pilot Willie McCool, and mission specialists Michael Anderson, Kalpna Chawla, Dave Brown, Laurel Clark, and Israeli astronaut Ilan Ramon, would not go to the International Space Station. Their flight would require nothing more risky than orbiting the Earth.
Booster ignition and liftoff of Space Shuttle Columbia with a multitude of national and international space research experiments.
82 seconds after launch, what was later described as a suitcase-sized chunk of frozen foam insulation breaks off Columbia's external tank and strikes the leading edge of the orbiter's left wing.
Roger, roll, Columbia.
A routine same-day video review of the launch would reveal nothing unusual. However, higher resolution tracking camera film processed overnight and reviewed on flight day 2 by the mission's ascent team showed otherwise.
You saw this little thing float toward the leading edge of the wing and like, it was like a snowball hitting something and then just being pulverized. But when you saw it hit, we just winced. Because we knew, the vehicle's going 500 miles an hour or better. It was inconceivable in hindsight that you could have that kind of impact at the speed that the vehicle was going and assume that there was no damage. And that's what we allowed ourselves to feel comfortable that we were right and we were dead wrong.
Due to limitations in the visual clarity, the exact point of impact and extent of any damage could not be determined. If the foam strike had compromised Columbia's integrity, little, if anything, could be done to repair the orbiter in space. 1 week after launch, Mission Control emails the crew informing them of the debris strike. Save for a relatively minor problem with a leaky refrigeration unit, STS-107 had been without further incident. As scheduled, the order is given on the morning of February 1st for the Columbia crew to begin the landing procedure and come home to Florida. Traveling in excess of 12,000 miles per hour, the orbiter's belly begins to glow red as it descends into Earth's atmosphere.
FYI, I've just lost 4 separate temperature transducers on the left side of the vehicle, hydraulic return temperatures.
As reentry started and as the ground track went across the states, the ground track, of course, changes color. You can tell where the shuttle is over what part of the country it is. Well, that display stopped updating. In other words, that display froze in a certain position. Well, sometimes you have loss of data, you have some problem with the system on the ground where you'll have those kind of outages temporarily. Well, this lasted a bit longer. Then the call went up to the crew. A call went up and no response. Well, I don't know, I just began to feel uneasy.
Columbia, Houston, UHF comm check.
At speeds above Mach 20, the stress becomes too much for the orbiter.
We do not have any valid data at this time.
The suitcase-sized chunk of foam had indeed punched a bowling ball-sized hole in the leading edge of Columbia's left wing. Within seconds, internal temperatures spike, signaling the cascade of structural disintegration. Only 16 minutes from home, Space Shuttle Columbia breaks apart in the skies over East Texas. All 7 crew members are lost.
GC flight. Flight GC, lock the doors. Copy.
And at that moment, I knew we lost him.
The grief is heavy. Our nation shares in your sorrow and in your pride. And today we remember not only one moment of tragedy, but 7 lives of great purpose and achievement.
Within days, hundreds of professionals from federal and state agencies across the country arrive in East Texas. They are joined by local volunteers to help NASA recover and catalog debris from Columbia in the hopes of, literally, piecing together an answer to the accident's cause.
This is one of the many obstacles investigators are up against.
It was really heartwarming and very emotional for me to see all of these people from around the country come in to the piney woods of East Texas and spend days and weeks there marching out through the woods looking for bits and pieces of the orbiter and so forth. If anybody ever wonders about the strength of the backbone of this country, then they ought to have the privilege, like I do, to meet these people who have come here to do this. It shows you the fabric of what this country is made of.
Determined to return to flight, stronger and safer, the grounded shuttle program had taken a fresh look at itself.
During my watch, we lost the Columbia crew, and clearly as a flight director back in Challenger, we lost that crew. I think about those every day. Every day I come to work. I need to be very vigilant. I need to pay attention, and I need the people that work for us in this business to pay attention to what they're doing, because this is hard stuff that we do. It's very dangerous. We have not figured out a way to do a beam me up Scotty. Right now it takes a lot of hydrocarbons, moving at very high speeds through fuel pumps at very high temperatures, high pressures to get into space, and it takes a tremendous amount of effort to get out of space back in the atmosphere and get home.
I was sent out to David Brown's parents' home. I'll never forget this moment when Judge Brown looked at me and said, "Leland, my son is gone. There is nothing you can do to bring him back. But the biggest tragedy would be if you don't continue to fly and carry on his legacy."
Each of the remaining 3 orbiters was pulled apart and refurbished. New capabilities were devised for the crew and mission controllers to assess and repair damage while on orbit. Processes and procedures were also re-examined and reinvigorated. Crew safety would never again be taken for granted. Nearly 2.5 years would pass before the nation would see another orbiter poised for launch from the Kennedy Space Center.
By the time that we fly the flight, it's something that it feels like we have flown many times. So if things don't go well, it becomes very, very natural for us to know at certain points during the mission, if this doesn't go well or if this significant system breaks or we have this type of emergency, what's the most important thing we need to do now, because we've been rehearsing it. And it makes it look really easy. You don't really get the full effect of how much real preparation, how much real studying went into making it look that easy.
Of all the changes accompanying the shuttle's return to flight, none was more significant than the one announced in early 2004 at NASA headquarters by President Bush.
Our first goal is to complete the International Space Station by 2010. We will finish what we have started. We will meet our obligations to our 15 international partners on this project. The shuttle's chief purpose over the next several years will be to help finish assembly of the International Space Station. In 2010, the Space Shuttle, after nearly 30 years of duty, will be retired from service.
Even though each shuttle was designed to fly 100 missions, the Columbia Accident Investigation Board called the shuttle an aging spacecraft, with the odds of losing another orbiter and crew increasing with each subsequent flight. NASA's human spaceflight program was faced with several basic challenges, including coming up with a successor to the shuttle fleet. However, with an impending cancellation of the shuttle program looming, shuttle managers recommitted themselves to the paramount task of safely completing the International Space Station. It would become the program's mantra, to be repeated over and over again, not only to the media but also for every worker in the shuttle program. No launch schedule was too tight and no mission too important to be rushed.
We ought to treat every flight, in a sense, as a return to flight. This is truly a test program. We go back, we make sure everything is right, we double check, and then we go commit in a flight readiness review that we're actually ready to go fly.
On July 26, 2005, Discovery gets the shuttle program flying again.
This is Shuttle Launch Control at T-minus 3 hours as our pilot, flight engineer. We're now into the suit-up room.
LRD.
LRD is go.
SRO.
SRO is go. So on behalf of the many millions of people who believe so deeply in what we do, good luck, Godspeed, and have a little fun up there.
Well, thanks to you, to the launch team, and to everybody in the shuttle program. The crew is go for launch.
T-minus 10 seconds. Go for main engine start. 7, 6, 5. 3 engines up and burning. 3, 2, 1. And liftoff of Space Shuttle Discovery, beginning America's new journey. And the vehicle has cleared the tower.
Among the many changes instituted, the new R-bar pitch maneuver or backflip.
Station Discovery initiating RPM in 3, 2, 1, march.
Will be used by each mission to the International Space Station. At arrival, the end-over-end flip allows the station crew to visually document the condition of the shuttle's belly and nose. Discovery and the STS-114 crew safely began the final phase of the shuttle program's historic journey with a smooth pre-dawn landing on August 9, 2005 at the Edwards Air Force Base, California.
Stevie Ray, Suichi, Andy, Vegas, Charlie, Wendy, and Eileen, welcome home, friends.
With this practically rebuilt space transportation system, each remaining shuttle mission would be safer than the one before, and its final flight, the safest.
It's almost like we've had kind of 3 different space shuttle programs. First 10 years, we're off learning how to fly the thing, deploying satellites and flying laboratories in the back. Next 10 years, we're doing more of that, and we're going out on more and more spacewalks, and we fly up to the Mir space station. And in the last 10 years, we use it to build about a 1 million pound space station in orbit, which wouldn't have been possible without Shuttle. It's a heck of a machine.
When you look at the Hubble Space Telescope, that would not have been possible without Shuttle, and you look at the International Space Station, which certainly would not have been possible without Shuttle. Every launch is an emotional experience. Watching what this nation has done, what NASA has done with the NASA contractor team, it's awesome. It's wonderful.
We didn't spend a dime in space. Not one single penny has been spent in space. Every single penny that went into the Space Shuttle program over its 30-plus years was spent right here on Earth. One, creating jobs, growing our economy, creating technological development of which we never dreamed, advancing science and technology, even advancing the field of aeronautics.
It just impresses me what people can do. What people can do. It's a big machine, it's a nice machine, it's a fantastic engineering marvel in my opinion, the whole space shuttle. But what's the real marvel is the people behind it that make it go.
Having a space shuttle enabled us to be able to complete our science and do some really great things to advance the area of metallurgy.
Without the space shuttle, an experiment like this one could not have been conducted. The shuttle is very important for us to learn and be able to conduct long period experiments.
Out of the 50 states, 48 of them have vendors that provide parts or equipment to the space shuttle program. So it's a vast cross-section of America that makes the American space program what it is.
Change is inevitable. As much as people don't like change, it's the only thing that's constant in our lives. And we have to change, we have to transition from shuttle to a new future, which we're going to define, which can be even better. A future that allows us to explore beyond our home planet, to seek our destiny, to learn what we couldn't possibly learn if we were stuck in low Earth orbit.
And since its return to flight, the shuttle program has been almost singularly focused on completing construction of the space station.
I think back of all the challenges and all the things that had to work right, You know, a lot of these interfaces never came together before. All the shuttle flights, the 20-plus shuttle flights that went into assembly, all the Soyuz flights, the Progress flights. To see this station come together in assembly is a true testimony to the international partnership. This is probably the most amazing research facility ever constructed in space, and it's constructed internationally, and it operates every day, 24 hours a day, doing world-class research internationally, and there is no more amazing facility than what we have in orbit.
Through and possibly beyond 2020, the ISS will serve as the world's first full-time research laboratory in microgravity. Among zero-G experiments already conducted aboard the station, several have led to promising breakthroughs in the research and treatment of cancer. Many other on-orbit science findings have the potential to significantly improve the quality of life back on Earth. In May 2009, Atlantis and its STS-125 crew took to space not to visit the ISS, but to return to the Hubble Space Telescope for its final servicing mission. On 5 spacewalks, Atlantis astronauts repaired and upgraded the Hubble telescope to significantly improve its capacity to explore the depths of the universe until at least 2014.
I think of all the fingerprints that are all over this thing.
It's a phenomenal piece of machinery. It's a phenomenal airplane.
And it really is an engineering marvel.
The space shuttle will go down in history as one of the great flying machines that America has produced.
The space shuttle, you know, at this time was a vehicle for bringing people together from all around the planet and having us work in harmony for the betterment of humankind.
We may not have understood when we first built it what all we'd be able to accomplish with it. And after many years, we've realized just how useful it has been.
It's been a learning experience on how to operate and live in space.
What can you say about the space shuttle? It has changed everything.
Well, the shuttle, from my perspective, is one of the great things that this nation has done.
It was a lot of pride.
Like I said, it's inspiring to come to work every single day to work on this program.
I'd go tomorrow if I had the opportunity.
Liftoff of the Challenger of Columbia. Discovery, the shuttle has been landed.
For more than 30 years, the fleet and thousands of Americans dedicated to its safety and success have toiled in exhilarating triumph, heartbreaking tragedy, and most often, quiet obscurity. Their contributions have extended beyond the bounds of space. Among others, shuttle-derived technologies have been used in developing an artificial heart and limbs, three-dimensional biotechnology, a light for treating tumors in children, and improving crime prevention and wildfire detection. From crawler driver to payload specialist, from scuba diver to pilot, from scientist to engineer, they and many like them throughout the nation share a commitment to sending humankind safely into space. That dedication, as much as any other acclaim, will be the legacy of America's space shuttle.
I think we'll be remembered in thousands of years, you know, as perhaps the most incredible technological feat of humans of our time.
As is the order of life, an ending for the space shuttle becomes a beginning for a space-bound successor. Soon, America will again send astronauts into orbit and beyond to do what NASA does best: